Okay. So we're talking about average rate of change. I want all of you guys to close your Chromebooks because I want you to pay attention to our notes. And you can finish your quizzes when we're done, okay? You got plenty of time today. It's gonna take us less than 15 minutes to do your notes. So our first function, so these are the single questions in Delta Math. Remember, you don't have to do the single questions. You only do the ones that are 3 or 2 or 5, right? 2, 3, 5. I don't think I assigned any that have 4 examples. So if it's a single question, I don't want you to do it because we've already done it in class together. Given the function defined in the table below, find the average rate of change in simplest form of the function over the interval 1 is less than or equal to x is less than or equal to 9. So really what this is saying is find the slope between the two ordered pairs 1 something and 9 something. So we're really just finding the slope. So tell me, when x is 1, what is y? 38. And when does everybody see that? When x is 9, what is y? 14. Kenneth, are you taking notes? Okay. So is y getting bigger or smaller? By how much? What's 38 minus 14? That'll tell me how much smaller it is. So I'm taking away 24. It's getting smaller. I'm taking away. What about on the x side? Is x getting bigger or smaller? How much? By positive 8, right? If it's getting bigger, we add. So change in y over your change in x. -3. So your average rate of change is -3. Yeah, AVE, sorry. Okay. Does that make sense? Okay, let's look at the next one. The next one doesn't give us a table. It only gives us a function. So basically an equation. So if I'm given an equation, what do you think I should do with that? Yeah, put it in your y equals. And that should say +4. Do you guys see that? This should say +4, not =4. Sorry. So x squared minus 6x plus 4. Put that in your y equals. And then how do I get a table? Yeah, that's what I want. So I want to know what happens when x is -2. And I want to know what happens when x is 5. All right. So Christian, when x is -2, what is y? You don't know how to use y equals? Okay, we've done that probably 1,000 times. Y equals, press the y equals button. X squared. So x is right here. Y equals x squared minus 6x. That's negative, not minus. This is minus. Minus 6x plus 4. Second graph. Okay, that gives your table. So when x is -2, what is y, Christian? 20. Okay. When x is 5, Kenneth, what is y? Did you put it into your calculator? No, you're just laying your head on your computer. Put it into your calculator right now. Y equals. Jameson, what did you get when you let y equal 5? What did you get on your table? -1. Good job, sir. All right, let's look. Is y getting bigger or smaller? By how much? -21. Good job, Jameson. Can I tell you guys how I think about this? I think about how long it takes me to get to 0. Like when the signs are different. Let's see. 20 to 0 is -20. And then 0 to -1 is -1. And then I just kind of add those two together. That's how my brain does that. Same thing over here. See how the signs are different? I'm getting bigger. What do I take? Like, what do I do to -2 to make it equal 0? I add 2. What do I do to 0 to make it equal 5? I add 5. 2 plus 5 is 7. So my change in y over my change in x gives me an average rate of change that is equal to anyone. -21 divided by 7 is what? Michael, say it. -3. Okay. So were you paying attention to what I did? Okay, let's pay attention. You got your brain engaged, right? When the signs are different, the top one is negative and the bottom one is positive, I think to myself, okay, what do I do to -2 to make it equal 0? And I said, well, I add 2. And then I said, okay, well, what do I do to 0 to make it equal 5? And then I said, well, I add 5. And so 2 plus 5 is 7. That's how I do that without a calculator. I just take the top and get it to 0. And then does that make sense? Okay. Good question. All right. What about this next one? It says the function y equals f of x is graphed below. What is the average rate of change of the function f of x on the interval -9 is less than or equal to x is less than or equal to 4? Well, let's just go see where the y is when x is -9. So when x is -9, y is all the way down here. Do you guys see that? And when x is -4, y is right here. How did you guys learn how to do slope on a graph in the first place? Do you guys remember? No? Nobody does that? Yeah, we counted rise over run. So what if I were to connect these 2 points with a line segment? And I just kind of drew my triangle. How much do I rise? How much do I run? The only warning that I'm going to give you is that you need to watch how the x and y axes are counted. So when I think about my rise, how much I go up, notice that this is being counted by 2s. Do you guys see that? So when I count how much I go up 2, 4, 6, 8, 10. I go up 12, and then my x-axis is just being counted by 1s. So when I run to the right, I run 1, 2, 3, 4, 5. So my change in y over my change in x. That's my average rate of change, because remember, average rate of change is slope. So you just have to be really careful about how you count your x and y axes. Like when I look at this example, my next example, my x-axis is being counted by 5s. Each grid line represents a 5. And then my y-axis, each grid line represents 200, right? So you have to pay attention to that. Luckily, on this example, they gave us ordered pairs. So this example says, hey, a function is graphed below. On which interval is the average rate of the change the smallest? So I'm going to calculate the average rate of change for each interval, and then we're going to look at the graph and see if we can decide something, okay? So when I look at this first one, I want to figure out what happens when x is 2 and what happens when x is 11. Well, when x is 2, my output is 624. And when x is 11, my output is 838. So is y getting bigger or is it getting smaller? It's getting bigger. By how much? Well, you could just take 838 minus 624 and you should get 214. Yes. Is x getting bigger or is it getting smaller? By how much? 9. So what is 214 divided by 9? Emily, 214 divided by 9. Please pick your head up. Thank you. 214 divided by 9. You're going to get a decimal, and that's fine. What? Can you say that again? Did you take 214 divided by 9? Yeah, I can't hear what you're saying. Just turn 23.7. Sorry, I just couldn't hear you, honey. 23.7. Okay. Let's go to the next one. I need to figure out what happens when x is 11, and the next segment is at 20. Well, I know that when x is 11, y is 838. And when x is 20, y is 1,324. Okay, so is y getting bigger or smaller? Bigger. By how much? Take the bottom number and subtract the top number. Yeah, 486. What about the x side? Is it getting bigger or smaller, Lionel? What do I add to 11 to make it equal 20? Yeah, good job. So you take the 486 and you divide it by 9. Jordan, what is 486 divided by 9? Say again. 54. Okay. Now I'm going to start with the interval 20, which I know has an output of 1,324. And then the next segment goes to 31. When x is 31, y is 1,631. Kareem, is the y value getting bigger or smaller? Bigger. By how much? Take the number on the bottom and subtract the number on the top from it. So 1,631 minus 1,324. Yeah, 307. What about the number on the y-axis? What's happening over there, Viviana? Is it getting bigger or smaller? By how much? 11. So let's see, I have 307 divided by 11 equals what, Savannah? 307 divided by 11. 27.9. Perfect. Last one. Well, I know that I'm starting at 31. So when x is 31, I know that my output is 1,631. And I think that the next x value is 38. 38 and 1881. Okay. Coral, is y getting bigger or smaller? How much? Yeah, good job. 250 bigger. Arlene, is x getting bigger or smaller? Bigger. By how much? That's the y side. What about the x side? By 7. Good job. So let's see. My change in y, 250, divided by my change in x, 7, gives me what, Angeli? 250 divided by 7. 25.7? Oh, 35.7? Perfect. Okay. So which one of these is the smallest? Yeah, the first one, right? Which is the interval between 2 and 11. That's this guy right here. Now let's look at the graphs really fast. Remember we talked about the slope of a line is the same thing as saying the slant of a line. Look at the slant of the first segment compared to the slant of the second. Which one is more slanted? Which one has more steep of it? Like if you were walking up it, which one would be harder to walk straight up? The second one, right? It's steeper. So we know that the second one is definitely not the smallest. So I'm going to get rid of that. Now let's compare the first one to the third one. again, if you, and here's another way to think about this. You can actually extend these lines forever, right? So if I think about this going like this compared to something like this, which one is growing at a faster rate? Which one is steeper, the blue one or the red one? Can you guys see it from the slope of the line? The top one is steeper. The one in this right here is a little bit steeper. So that's not going to work, right? So now you're just comparing this one to this one. And it looks like this one has more of a slant. If you can't see that, the method that we used works very well, but I was hoping that you could see it from the slant of a line. That's okay. So just calculate the rate of change or the slope from each interval. Got it? Okay, we have two more examples, I believe. So the function y equals f of x is graph below. Plot a line segment connecting the points on f where x equals 7 and where x equals 8. And then you're going to use that line segment to determine the average rate of change. And you can't get through this activity without plotting your points. So I have to see what happens when x is 7. And then it's going to start drawing a line for me to when x is 8. So I know that's really tiny. Those are really close together. I'm going to kind of blow it up. You really, really, really need to pay attention to how your x-axis is counted and your y-axis. My y-axis is being counted by 5s. My x's are being counted by 1s. Do you guys see that? So when I think about my slope, I'm going to go down first. How much am I going down? I'm not going down 1. How is the y-axis being counted? Yeah, I'm going down by 5. And then I'm running to the right 1 unit. God bless you. So my change in y, that's what this represents. This little delta symbol represents the change. The change in y is -5. The change in x is 1. And -5 over 1 is the same thing as -5. Okay. Remember that this little symbol, it's called a delta. It represents just the word change. You guys should see this when you get into like chemistry. Okay. All right. Last one. So again, this is another one in Delta Math where you have to like plot each point and then connect it with a segment, and it won't let you move on until you do that. So we're looking at this graph and we're calculating the average rate of change from -2 to +3. So when x is -2, y is 0. And when x is +3, y is -10. Okay. So you have to draw a segment in between them. You have to draw a line segment in between them. And you have to calculate your slope. How much do you go down? How much do you run to the right? How is the y-axis being counted? And when I say that, I mean like, what does every grid line represent? It's by twos. It's being counted by twos, right? 2, 4, 6, 8, 10. So each grid represents 2. So I'm going down 2, 4, 6, 8, 10. So that's -10. My x-axis is being counted by 1s, right? 1, 2, 3. So I go to the right. 1, 2, 3, 4, 5. So my change in y over my change in x gives me what answer, Peyton? What is -10 divided by 5? -2. Okay.